The first of Europe's ExoMars missions is complete and has left the Thales Alenia Space Cleanroom in France. The Trace Gas Orbiter and its entry, descent and lander demonstrator, Schiaparelli, are now heading to the launch pad in Baikonur. ExoMars 2016, a joint mission between the European and Russian space agencies, will launch in March on a Proton rocket and arrive at Mars in October.
The two vehicles will separate 3 days before landing, and the TGO will go into its capture orbit to go around Mars, and the Schiaparelli instead will land on the surface of Mars.
Schiaparelli will be the first spacecraft to descend through the atmosphere during the planet's dust season. The Amelia investigation will study science during entry and descent, and CoMars Plus will monitor the heat flux experienced by the back of the lander. This will provide valuable information for future missions and help scientists understand the electrification processes in Mars's atmosphere. Its descent camera, DECA, will image the landing site and measure the atmosphere's transparency. As the lander's main goal is as a demonstrator, it will land somewhere well studied, Meridiani Planum, where NASA's Opportunity rover landed. The lander includes a science package called DREAMS that will study the Martian environment for several days. In 2004, ESA's Mars Express was the first spacecraft to detect methane on Mars. This finding was backed up by measurements from Earth. More recently, the Curiosity rover detected variable spikes of the gas. The ExoMars Trace Gas Orbiter will measure trace gases in the Martian atmosphere, including methane. On Earth, most of our methane comes from life, even bacteria, but there are other possible sources, such as hydrothermal reactions between water and some minerals in the mantle, for example olivine.
There is a process in the mantle that turns this olivine into a different mineral called serpentinite. This action with water releases a lot of hydrogen. Now, on a planet like Mars that has a CO2 atmosphere, the hydrogen can react with the CO2 to produce methane. The interesting thing is that whether it is the bacteria or the hydrothermal reactions in the mantle, in either case you need liquid water, and in both cases it points to a planet that, if you like, is more alive than what people thought until now.
The Trace Gas Orbiter will serve as a data relay for the 2016 and the 2018 mission, which will contain a rover and a surface science platform. In 2018, the European-led rover will not only drive across the surface, but also drill 2 meters below it to collect samples and analyse them using its next-generation instruments. The collaboration between Russia and European space agencies is one which will expand our knowledge of Mars, searching for important clues to help us understand if there has ever been life on our neighbouring planet.